All right, I'll go ahead and get started since it's 5:30 and I have a whole lot to get through. So, my name is Korando. I'm a Java developer advocate with Oracle, and you can find me on the Bird app at Korando, where I spend too much of my time. Real quick, one thing I want to ask is, how many people here are on Java 17 or even Java 18? A few people. How about Java 11? A good amount. Java 8? Okay, well, hopefully, this presentation for both people in Java 8, definitely in Java, even in Java 11, will convince them to upgrade to Java 17 or even 18, because there's been a lot of great changes. Some important information, ask questions, so we may need to wait until questions at the end, because a lot to get through in just 50 minutes, but definitely ask questions, and if you don't get a chance to ask questions here, DM me on, or you can just tweet at me at Korando, or you can also email me at billy.korando@oracle.com, or you can go to this presentation, or go to this link to this presentation. I do have like 2 Java N and beyond, and that's just because I continually will be updating this presentation as new releases come out. So this presentation will always be kind of up to date, or at this link, with whatever the current state of Java is. If you would like to know more, we have a lot of great information. So at these links at dev.java, where we have tutorials and also ways to get connected to the community, finding great conferences like Spring I/O, Insight.java, which gives information on the developers of OpenJDK. Like, we may have like an interview with like Ron Presler and like implementing Loom. We also have our YouTube channel where you can find a lot of great information, including our Inside Java podcast recordings, Inside Java newscast, and also Mondays I release a 1-minute video called Sip of Java on Twitter, and now we're also putting it on YouTube, which covers various Java topics, and we also have the Jeff Cafe as well. I've been experimenting with a new, so I've been, we've all been in lockdown for the past couple of years. I've been just using PowerPoint that time. Then I did my first in-person presentation. I'm like, ooh, this does not look so good. So I've been changing it to Reveal. There's a couple little graphical fixes that I need to go through. So sorry about that for that being a little goofy looking there. I need to kind of fix a couple of things, but hopefully this will be better. So the agenda, we're going to be looking first at the new language features, then a bunch of API updates, new runtime features, then some of the deprecations, removals, and other changes to know about, and then we'll go into some of the preview and incubator changes that are going to be coming then in future releases. So new language features. The first one I'm going to talk about is text blocks. These were added in Java 15, and the JEP for them is 378. If you're not familiar with the term JEP, that stands for JDK Enhancement Proposal, and whenever there's a somewhat substantial change added to the JDK, it goes through the JEP process. And you can go here to openjdkjava.net, JEP/0, though actually this should be openjdk.org, JEP/0, so that should be easier to follow. But this will give you all the different JEPs, and like I put, that was 378. If you were to then put 378 at the end there, or you were just scroll through and find it, this will give you more detailed information about this new feature, more than I can kind of go to during this presentation, because, well, there's a whole lot to get through. So definitely check that out if you want more information on some of these features I will be covering in this presentation. But text blocks, simply put, they're adding 2-dimensional strings to Java. Of course, we're all familiar when working with like formatted languages as strings in Java code. So like in this example here, I'm working with a simple JSON message. And, probably because we're pretty familiar with this, we can kind of understand what's going on here, but it's still very dense and difficult to read, and also be very easy to make a mistake, especially as we maybe add more complexity to this JSON message. Maybe we get some nesting into it and stuff like that. It can be very easy, to forget to have a comma in here, or not, indent something properly, or forget to, escape a double quote or something like that. So there's a lot of easy ways for things to go wrong. So now we have 2-dimensional strings with text blocks, and they are denoted by triple double quotes. Thank you for that. And within the triple double quotes is a lot of the formatting requirements are relaxed, and now also this text here, this is how it would actually be rendered by the JVM if you were to print it out, preserving all the white space. And again, we don't have to, escape out the double quotes here. We don't have to add new line characters. We don't have to add any tabs or anything like that. The enclosing triple double quotes is important. So really effectively where you put those triple double quotes is where all the white space to the left of that will then be ignored. There's a little bit of rules around that, but really you just probably want to align it with whatever white space you want to have to be ignored to the left of it, and you'll be good there. Fundamentally, though, these are just normal strings. So like, for example, here with another JSON message, if I wanted to be able to use the string formatting to insert values into it, I could do that just as well as I could with a one-dimensional string. Again, these are really just fundamentally normal strings by the JVM standard. It's just another way of declaring it within the code itself. Now, if you maybe had like a huge amount of text, but you wanted it to all be printed out as a single line, or you just wanted to have some of these character turns ignored, as a very last character on a line, you will want to put a backslash, and then that will ignore that character turn. So you can see here, I put backslashes at the end of each of the lines, and then this is all printed out as a single line of text. But just make sure that's the actual last line. If I was to put a space after that, then it would put a new line within there. The next I want to talk about is switch updates. These were added in Java 14, and the jet for them is 361. So of course, again, we're all familiar with the original colon syntax for switch updates, and it is visually noisy because, well, we need to have all these break statements. And this visual noise, it's not just makes it a little bit more difficult to work with, but it's also an opportunity for introducing bugs, because we've all had that time where we maybe have some sort of switch case, and then maybe we're refactoring or doing something, and we ended up commenting out a break statement, and maybe we just didn't have a test case that covered that specific case within your switch statement, and then all of a sudden now you have a bug in production. So now we introduced the new arrow syntax, so where whenever a case is matched, only the code to the right of that arrow syntax is executed. So not only is this much cleaner and easier to read to understand, saying like, okay, you can match on case 1, we're going to print out Sunday, but it's much less prone to introducing bugs because we don't have to put those break statements in each of the cases, which is again something that was done because I believe it was copying off of Fortran or C, where pass-through by default was a thing, but it ended up not really being a thing many developers, Java developers, really wanted. Also with the switch updates, they can now also be written as an expression, so now values can be directly yielded out of the expression. So, of course, all the cases would have to match to whatever you're returning to or be an appropriate type. In this case, I'm having all strings. Expressions must be exhaustive. So most of the time right now, that means you'll have to have a default case, like in this example where I'm just throwing an exception because it's an illegal argument. But there is, at least right now, an example where you wouldn't necessarily need a default case, which I'll show here in a few moments. Also with the arrow syntax, if there is some sort of more complex behavior you want to have done than this one single statement to be executed, then you can use these brackets, and then within that, you can have that all be executed. In this case, with a expression, I end it with a yield statement. And yield is not a keyword, it's actually a reserved type name, so you can't actually have like a type declared yield anymore after Java 15 with this, but you shouldn't be declaring all lowercase types anyways. But yeah, it's not a keyword, so if you had like a variable declared yield somewhere, that would still be valid. But if this wasn't an expression, if it was just like a normal switch statement, then I wouldn't even need a break in there. It would just be once it gets to the end of that block, then it would, stop executing. But you can also do an expression with the colon syntax. You would just have to end each case with the yield statement. And again, you would still have to make sure it's exhaustive, so you would often need a default. Right now with switch for expressions, the only example where you wouldn't need a default case, it would be with an enum, where within the switch you do then reference all the different values within that enum. So in this case it's exhaustive, so I will no longer need a default case. And again, that would be the same with the old colon syntax if you still want that. So of course, the old colon syntax is still completely valid. You're not going to update to Java 17 and then have to completely rewrite all of your switch statements. That's still valid code, but now we have the arrow operator. The next item I want to talk about is pattern matching for instance of, added in Java 16, and it's JEPIS 394. And pattern matching is going to become a very important story in going to the future of Java. So, instance of isn't the most common language feature developers use, but we've all used it at least once or twice. And here in this example, like I have some sort of thing that's just an object and it's some number type. And so here's like, okay, if it's an integer, I set it, and then I have to then, declare an integer variable within like the if block perhaps, and then cast it as well, even though I know it's already an integer by this point. And maybe if it's not that, then it's a long, and so on. Again, somewhat visually noisy, sometimes an opportunity for also introducing bugs within that. So with integer matching or pattern matching for instance of, what we have here is we have a predicate, or maybe rather to do this for better for posterity, is we have a predicate here of some number type, does it match to integer? And if it does, then we set it to a pattern variable, in this case I. And this I then is what's called in flow scope. And flow scope is maybe somewhat a new concept to Java, where flow scope is that it is only in scope wherever the compiler knows this has definitely been set. So generally that means it's going to be in scope within the following block within that if statement here. So I would be in scope here, but it would be out of scope here following in the following if block, or anywhere outside of this if else statement. But for example, if here I want to do a match on, okay, is it an instance of integer? Then, okay, is it maybe greater than 100 or something? Okay, then, I do a large number. If the following, okay, maybe if it's greater than 0, okay, it's some sort of small number. And if it's less than 0, then it's a negative number. But the compiler, this is all different instances of I don't have to arbitrarily think up of different letters or different variable labels. So that's one of the nice things about the flow scope, that it all makes sense, and then you also aren't arbitrarily having to think up of new variable labels just to not get any sort of conflicts. But to kind of just also drive home the point when it comes to flow scoping, so here, I is matched, and then it would be in scope here in the if block, but then it would be out of scope once we left it. Here, if I just was to do a match within this evaluation, again, it would be in scope within this evaluation statement, but then it would be out of scope the second I left it. And of course, it would also be out of scope if I did an R, because of course, the only way to get to the R is if this part of the statement was false. And you can get really weird with it. So if I was to put a not in front of this, then of course it wouldn't be in scope in the if block, but it would be in scope in the else. Or if I did a not and then a throw, then it would be in scope outside of that if block. But of course, don't do that, because that's just a bug waiting to happen, and it'd be very confusing for any sort of subsequent developer that came after you to understand maybe what's going on there. Sealed classes, these were added in Java 17, and their JEP is 409. So sealed classes is a way for a class to declare what can extend off of it, and how that could be useful, or at least in my experience from working as a developer, is a way of communicating certain domain concepts and actually putting it into code. So we've all worked with various different domain concepts at our organizations, transaction types, customer types, user types, and there might be only a limited actual set of different types of these. And before in Java, there was really no way to define that in code. You could put it into documentation, but there wouldn't be a necessary way to know. It'd be like, oh, for user, there's only 3 different subtypes of user, in this case, guest, customer, and admin. Now with sealed types, we can declare that. And so when you clear a sealed hierarchy, you would use a new keyword sealed, and then there's an optional argument of permits, where you would then say, okay, only admin, customer, and guest can extend user. Now, when you declare a sealed hierarchy, all these subtypes must then either declare themselves as either non-sealed, which effectively makes it a normal class, so anything can extend off of customer. You can also declare it as final in the case of guest, in which case, of course, nothing else can extend off of it. Or you can also declare another item, or admin in this case, also sealed, in which case, it can then say what it can extend off of it. But also keep in mind, permits is optional. So here in another example with admin, you'll notice I don't have the permits clause, and that's because within the same, if you declare other classes within the same code file as a sealed hierarchy, then the compiler just assumes that those are the classes that can extend off of it, in which case you don't need that permits clause. And indeed, if I put a permits clause within admin, that would give a compiler error. And the last new language feature I want to cover is records, and these were added in Java 16. And I think records are going to be one of the most important new features that have come to Java since lambdas and streams in Java 8. We just get the start of it here, but they're going to be extended farther in future versions as well. That'll make them even more useful. But all the same, they were added in Java 16, and their JEP is 395. And the first and most obvious benefit developers will notice from records is, well, they reduce a lot of boilerplate code. So here we have the example of, maybe I just have like a few fields I want to then put into like some sort of throwaway type that really makes only sense within this method. Well, if I wanted to declare that type within this method, it quickly becomes dozens of lines of code to properly declare a class, even in the simplest terms, when you consider, the equals and hash code and all that. So, within a method, this becomes very distracting. They'll be like, oh, okay, this is the start of the method. Then you have all this visual noise, and then this is the rest of the method. That would be very confusing to look at for another developer, or even the developer who wrote it 2 or 3 weeks later. So now, with records, all that can be declared within a single line. But of course, the point of records isn't to reduce boilerplate code, but to be able to transparently model data as data. So we want to be able to look at the definition of a record and really immediately understand what we need to know about it. So we look at the definition of the person example I had from before. Well, you can obviously see the name of the type and then all the fields that would be in it. So within records, within the parentheses here, these are called components, but when it actually gets generated as a class, that becomes the fields for that class. And the way we can then know that these are the only fields within that class, the only instance fields within that class, is because of the constraints put on record, such as a superclass of record is always going to be Java lang record, so it can't inherit any sort of behavior from some sort of superclass. And so then, of course, they can't be extended, they can't be abstract, and so as a result, they are all implicitly final. Also, all the fields within a record are final, so once they're set, they can't be changed, though this is only shallowly mutable. So if one of these fields, for example, was an array list, I could, of course, remove and add or remove items from that list, but I couldn't change the reference. You can't declare instance fields, so I couldn't, have, my fields up here, and then within the parentheses, within the body of the record, try to declare another instance field that will give a compiler error. Now, with these constraints, we do get some benefits. The compiler will automatically generate the accessor hashcode toString equals for you, but you can also override these default implementations with your own, or also add your own method definitions. Fundamentally, they are just normal classes, though of course when you override the default implementations, particularly like hashcode and equals, you want to make sure you're not somehow breaking the expectations. If, in your equals, you're no longer comparing all the fields for equivalency, that's going to cause a huge problem. So probably hashcode and equals you generally don't want to override, but it could be making some sense for some other ones. Like for example here, Instead of like the standard toString where it's just like the name of the field or the name of the class and then the square brackets and then the different fields, maybe I want to have some sort of prettier printing out of it. You could do that. Or, of course, like I said, you can just declare your own methods within it. Like here I want to print out JSON, so I can do that. And here I'm also, again, using the text blocks. So I mentioned how records you can't extend, or they can't extend off of any other class, but they can implement interfaces. And this could be a good way of combining records with sealed hierarchies to create algebraic types. And we can see this example here. We have a sealed interface shape. And then in this example here within the same class file, I declare a circle record, a rectangle record, and a triangle record, all implementing shape. So that way, that's the only kind of interfaces or only kind of classes that implement shape as well then. All right, let's get into some of the API updates. The first is added in JDK 17 was the pseudo random number generators, and that JEP is 356. So there's always been like several different ways of generating random within Java, but they all had like slightly different interfaces and they weren't always compatible, which kind of made them pretty frustrating to use. So now there is a new interface, random generator, which provides a uniform API for all the random classes. And then there's also 4 new interfaces: splittable random generator, jumpable random generator, leapable random generator, and arbitrarily jumpable random generator. That all kind of reflects to certain things within random. I think splittable takes like a random generator and splits it in half to where you can use 2 different instances of it using the same algorithm. Jumpable, like jump a few in the different numbers within it, and so on. And then also there's also updates to the underlying algorithms to be more secure, or also do certain different behaviors within random as well. The next is the Internet Address Resolution SPI. This was introduced in JDK 18, so this is one of the first things that comes Java after Java 17. Its JEP is 418. And this is part of a kind of change to kind of address some future support for things like Loom. But yeah, we provide a server provider interface for hostname internet resolution. And by default, this isn't going to change anything. So by default, even if you update to Java 18, how your internet address resolution wouldn't really change unless you declared a change for it. But the purpose is to be able to easily provide different resolvers that are supplied through the Java Service Loader. How many people a year have used a Java Service Loader before or have heard of it? One. It's always one. Like no matter how many people are in a presentation, it's always one person that has used it and never more, and never less. But all the same, the Java Service Loader is a way of kind of loading different implementation details at runtime. But again, the reason this was added was for things like Loom, which, Jürgen talked about both during the keynote and then also if you went to his presentation, where we're going to need better ways that aren't going to create blocking and threading issues. But it could also be really great for testing support. So if you're doing some sort of testing that needs a call out to a internet address, instead of maybe actually having to make that call, you can supply your own mock internet address resolution just to make sure, like, yep, it's calling the correct URI. It doesn't really need to actually make that root call to maybe make your test run a bit faster. And this could also be really great to work with frameworks, like Spring. Maybe they want to put in their own internet resolution resolver as well for whatever particular purpose. Code snippets in Java API documentation. So maybe within your code, within your Javadoc, you want to, like some sort of example code of how to use some sort of API. If you're writing this for applications, this doesn't make much sense, but maybe if you're writing for a shared library at your organization, or of course, if maybe you're a Spring developer and you're writing for the Spring framework, this would make a lot of sense. Before, we always had the code brackets, but they couldn't do any sort of highlighting for it, and it was a little bit difficult to work with, and it couldn't be validated. So now there's the new snippet annotation, where this could also allow for code highlighting. I don't show examples here, And there's also a few things where you can also replace values within it. But importantly is that this code can also be discoverable by the compiler API so that it can then be validated. That's not natively part of the Javadoc tool, but that's something that can be done with like a third-party library or a third-party tool to check the code to make sure that it's valid, so that way if things change over time, you can catch that to make sure your documentation is always up to date and valid. So codes can be written inline, like in this example, or they can also be referenced to external files, so that way if you have a really complex example that you want to put into the code, you won't necessarily have to have a dozens of lines long Javadoc code snippet. You can move that into a separate file, so that way it's a bit cleaner than within your code. Simple web server. I'm actually running this application off this simple web server. So what this was done is just a simple way with this, simply with JWeb server, to start up a server that serves the files from which the directory you're running the command from. This is just kind of catching up with some other things like Python. I've noticed has had this for a really long time. And it's just something, this is particularly requested from the academic world, where many students, at some early point will just need to write like a simple web page. Well, now you can do that without having to go get some other SDK or having to download like an application server just to do that. Now we have a really simple web server implementation directly packaged within the JDK. And as you can see, it starts serving at the loopback address on port 8000. It'll serve files from the current directory and then subdirectories, and the MIME types are auto-configured. So if you had .html, it will serve it as HTML. If it was like a .java file, then it would serve as text. There's also ways to configure it. So if you wanted to do a different address, you would pass the -b value or parameter. If you wanted to have it some sort of different directory, you could pass it -d, which could even be a remote directory, but you must use a full path. So you can't be like in a directory and do -d and be like, oh, I just want to serve the subdirectory and just, reference the directory name. It would actually have to be the full path to that directory. And you can change the output as well. The info is default, but if you want to set it to verbose or none, you can just do that as well. There's a lot more API updates that I simply don't have the time to get into. But if you go to the official Javadoc, there is a new tab at the top that says new, and if you click on it, it will show like either new classes, new packages, new methods, and so on for everything that has changed since JDK 11. That's really helpful, particularly some classes that are heavily used, like string and stream, have seen a lot of updates to them since JDK 11. So this is a really good way of kind of going out and exploring maybe what is new. And so if you are updating from JDK 8 or JDK 11, definitely give this a look just to see all the things you may have missed, because there's a lot of really great new updates to a lot of those classes. All right, let's get into new runtime features and also some other improvements. CDS updates, class data sharing. How many people have heard of class data sharing? One? Okay, so that, well, Nino asking about that. Class data sharing is really horribly under talked about feature within Java, so you'll get a chance to learn about it here. So particularly because JDK 10 introduced the concept of app CDS, or application class data sharing, and then JDK 12 introduced default CDS archive. So just to quickly cover that, CDS goes all the way back to JDK 5. And what happens is every time your JVM starts up, it's going to have to load a bunch of classes from like the core Java library. And of course, every time you're starting up your JVM, it's going to be doing that same behavior every time. Loading all these classes up from the file directory to where it can actually then run the JVM. So that's obviously an opportunity for a enhancement. So in JDK 5, they added that ability to load from like a pre-processed archive that helps speed up the startup time. In JDK 12, they finally added it to where the shared archive is now available in every download you get of the JDK across all the different platforms. Initially, it was just on Windows, and for every other kind of platform, you would need to create your own. In JDK 13, they made it to where AppCDS is easier to use. In JDK 10, between 10 and 12, it was a 3-step process to use it, which is confusing, and it wasn't really greatly documented. Now it's a simple 2-step process to where you say, you'll use Java, and you'll just say, okay, archive classes at exit, and then you'll give a name to this shared archive, and then then you just run your application as however you would. On the follow ones, then you would use this shared archive, and then of course the same name, and then of course the state startup. So what this does though is, again, it pre-processes all the classes that would be loaded by your application, like all of its underlying dependencies, into a pre-processed archive, which significantly speeds up runtime or startup. So when I'm running like the Spring Boot Pet Clinic app, I don't know if many people are familiar with it, but it's a simple POC application put together by the Spring team to demonstrate Spring Boot. And normally, like on my laptop here, it takes maybe 5 or 6 seconds to start up. When using AppCDS with a shared archive, it knocks off about like a second and a half. So it's maybe 4.5 to 5 seconds to start up. For doing something pretty easy that takes just a few moments to write. Also, if you're running multiple JVMs on the same host and they're all referencing the same shared archive, it's memory mapped, and that could actually have a pretty significant memory savings as well. Again, that's only if you're running multiple JVMs from the same host. Another couple of nice things is that it's very resilient. So like, let's say the JVM can't find the shared archive, then it will just ignore it and just load it from the file system. So it's not like if this archive went missing, that it's going to cause your applications to fail at startup. Also, like let's say many people here are probably using Spring Boot at your organization. You wouldn't necessarily need to go and create a shared archive for every single application, because your underlying tech stack is probably pretty similar across your organization or maybe across your team. So just really can create one shared archive, and it will just load, because most of the code that's actually running would be your underlying dependencies, not the actual first-party code that you've written. So you can just kind of write one that has like all your Spring Boot stuff within it, and then all the other applications can just load from it, and you'll get 99% of the benefit from it. So really, definitely check it out, just because it's like a really easy way to improve your startup for very little risk and with very little difficulty. The next item I'm going to cover is the newest garbage collector we have, which is Z, which doesn't really stand for anything. I guess they just felt the garbage collector developers just felt like Z was a pretty cool, or Z was a pretty cool name, so they just went with it. It was initially introduced as an experimental feature in JDK 11, but now it's a full production feature with JDK 15. And it has extremely low latency. So here I say it's under 1 millisecond pause times, but really that doesn't do it justice. That even on other testing, it rarely gets over 250 microseconds for the pause time. So it's virtually no pause times, and that's like the max of the pause times. Most of the time it's like 100 microseconds. So it's extremely fast pause times, and it's also extremely scalable when it comes to heap. So it can have between 8 megabytes to I think 16 terabytes of heap. And also is that the pause times don't increase with heap size. So whether it's 8 megabytes or 16 terabytes, the pause times should always remain about the same. Currently, it's only single generation, which only really means something if you're really deep into garbage collection. But it's hopefully you can become multi-generation soon. And really what that just means is how efficient it is with having to run garbage collections in memory. But to use CDC, just simply do x plus or xx and plus use DDC, set your heap size, and maybe when initially using it, you want to turn on logging GC and maybe even use something like JDK Flight Recorder to kind of see what behavior is going on. And if you're not familiar with JK Flight Recorder or you want to learn more about it, I'll be doing a presentation on it tomorrow at 10 o'clock. So definitely check that out for things about application profiling as well. Next, I think this is going to make every Java developer happy because we've all run into null pointer errors at some point, or exceptions at some point, and they're really frustrating. But yeah, JK14, JEP358. You know, here I just have like a simple example, and here it's like, okay, you know, I'm referencing, trying to get like a value off of my record. And, you know, in the old way, just be like, oh, an exception happened on line 14, which, you know, granted in this simple exception would be pretty obvious that it's my record that's null. But now it will actually say, hey, an exception happened here, and it's because this my record is null. So it will actually tell you what value within that line was null. So that will make it just that much easier to hunt down those null pointer exceptions when they inevitably come up. Also, AMD architectures, or not AMD, ARM architecture 6.4 support is now supported across all platforms. So Linux was the first with JDK 9, and then Windows was 16, and Mac OS is the last of the major platforms with JDK 17. So if you have one of those really cool M1 MacBooks, first just give it to me. I would really like that over my older Intel one. But now, you know, you should probably notice a pretty noticeable performance bump by using JDK 17, just because it has that native support for ARM architectures. Performance improvements. I didn't want to really put any specific things on here just because, you know, all those charts are very specific to what's going on, but you should notice pretty significant performance improvements when, especially going from JDK 8 to 17, but even from 11 to 17, you should still notice pretty significant performance improvements. Every release, there's just a bunch of performance improvements that are in there, you know, addressing things like I know in JDK 17, like for example, string format, like one of our engineers found a way that improved its performance by about 3-fold. But you know, there's things like that just kind of build up with every release. A lot of changes with how we do things with garbage collectors. All saw significant improvements across performance when it comes to throughput or latency or startup. So just updating to 17, you should see pretty significant improvements. How much? It's going to vary very much depending upon how what your applications are doing, how they're written, and all of that. So I can't give any sort of specific, you know, answer or number, other than to say it should be very noticeable. And again, that should be across many different factors, not just like say throughput or something like that. Oh, I forgot one other thing just to mention. So with Z2C, like I said, the goals of it was to be ultra low latency and also be extremely scalable. It does come with like a bit of a throughput, like it's a little bit slower on throughput, maybe around 10% or so. So that's at least something to keep in mind if you want to switch to it. But again, that may vary a lot depending upon what your application is actually doing. For deprecations, JDK, so how many people have used the security, how many people have heard of the security manager? A few. How many people have used it? No one. So that's why it's being removed. And actually, really, the main reason it was actually even there in the first place was because of the applet API. So the security manager was a way of configuring, saying like only these packages or only, you know, these specific areas of the code can do these specific privileges. But most of the time, what we're actually writing is code that we've all written ourselves or that we're bringing in from third-party libraries, which of course we can do static analysis for security vulnerabilities on. We don't need to do that stuff at runtime. But the reason why Security Manager was there was when we were doing applets, where of course with an applet, you're bringing in some sort of third-party API to run in your JVM, at which point, of course, you would want to say like, okay, only my packages and only my classes, you know, can, you know, make changes to the file system or something like that. You know, this applet that comes in shouldn't be able to do anything. But with applets going away and really having long since, you know, effectively being killed off because of all the browsers no longer allowing it, it really also meant with it that the security manager really didn't make much sense. And ultimately also pretty much anything you can do with security manager at the application level, you can also do at the operating system level as well, which is just easier to use and understand. So because applets is going away, so such a security manager, just because there's also a pretty high maintenance burden when it comes to supporting it. Also, in JDK 18, finalizers are going away. Again, how many people have heard of finalizers? A good amount. How many people have used one? Only a couple. Again, that's part of the reason why. And also because, well, really finalizers don't work the way they're expected. So what finalizer is you can add the finalize method to your any class because it's implemented in an object, and that allows you to then remove resources like, say, file handlers or JDBC connections or whatever you want at that. The problem is that finalize, you don't know when that's actually going to be called by the garbage collector, and also within finalize, you could resurrect objects that then will just stay there and can't ever be actually reclaimed by the garbage collector. So there's a lot of ways where finalizers could just cause issues and then not work the way you expected, leading to a lot of resourcing issues. So again, that's why they're going away. This is all deprecation for removal, but how long they're going to be before they're actually removed, it's going to be some number of years. So it's not like if you are heavily dependent upon these things, they're going to have to really worry about that in the near future. For removal, now storing the JavaScript engine, that's removed. It's still somewhat supported on OpenJDK, so if you still need to use it, it's still actually available out there. It's just no longer packaged with the JDK. On the concurrent mark sweep garbage collector, that was removed in JDK 14 just because the G1 garbage collector just was designed to replace it, and it became the default garbage collector with JDK 9, so this no longer made sense to have the concurrent mark sweep garbage collector. Again, if you're not really caring too much about garbage collectors, that doesn't matter too much, but something to keep in mind if you are using it. Other changes. So starting with JDK 9 with the much heralded, sarcastically, the module system being introduced, that started this path of more strongly encapsulating the JDK internals, and we're getting more closer to that with JDK 17, where initially when JDK 9 was introduced, the illegal access permits was a default argument to the JVM, which kind of bypassed all the behavior of strict strongly encapsulation provided by the module system. In JDK 16, illegal access permits was no longer a default argument, and now JDK 17, illegal access permits is it's no opt. Still, some things like sunmisk, unsafe, and others are still available for reflection. But if you need to reflect into other modules, you'll actually need to declare that within like a module hierarchy or with arguments as well. So there's still ways to do that, but you just don't get this easy parachute opening of illegal access permits to completely undermine the entire module system. All right, to quickly go through a few of these preview and incubator features coming. Pattern matching for switch. It's currently in its third preview with Java 19, and what it's going to allow is a when clause to where you can do like a case. You can, again, this is an example of obviously it is pattern matching. So we have our predicate where we're testing to see, okay, is this value a triangle? If it is, assign it to T, and now we can also have a guarded when clause to where you can also then check to see like, okay, if it's greater than 100 in size or whatever, to do some sort of behavior there instead of maybe always having to do like an if statement within a case statement. So it just makes it a little bit cleaner. Also added with this third preview was some updates to how null cases are also handled at runtime. Record patterns. Here it makes it much easier to deconstruct a record. So here in this simple record point, if I wanted to just extract the values from that record, assuming that object O is a point, I can then easily do that. And then also this provides null safety. So that way, of course, if point is null, or if object O was null, of course, it wouldn't then match on point here because it's null. It's not that same type. So that also kind of helps reduce some issues with having to check for null in a lot of areas. Virtual threads. This is Loom is finally delivering. And so the first preview of virtual threads here in JDK 19, and Virtual threads, again, if you didn't hear during the keynote or maybe during Jurgen's presentation earlier, it's a much more light way of handling threads. It creates a thread in memory that the JVM manages, and when a thread is not in use, then the JVM will just park it, and when it's actually needed, then it'll manually handle, like, okay, I'll find a thread, and then we'll run it for as long as I need it, and then once there's no longer active within that thread, then it'll again be parked. So it allows for much greater concurrency than is possible currently with the JVM, because you're not having to create a new thread every time. So that's going to really change things. Brian Getz kind of says how virtual threads, Loom, is going to really kill reactive programming within Java, because it's no longer going to really be needed because threads are going to be so cheap. The vector API is in its 4th incubator with JDK 19, and then there's also structured concurrency, and this is, again, it's currently proposed to get in JDK 19. Hopefully we'll actually get into it. Don't know for sure yet. That's its 1st incubator, and this is providing a library for better supporting concurrency that's going to be possible because of Loom, because, again, threads are going to become much cheaper to create because you're no longer actually doing it at the OS level. Whew. All right, I actually did barely make it in time. But here's some follow-up links. Again, here's a link to the JEPs. Always check out the release notes for every release. There is just a lot of fantastic information within them. I mentioned I do a 1-minute video every Monday on various Java topics. A lot of what I talked about I have covered in these 1-minute videos, so you can check out. Most of them are here, and we'll work on getting them all at this link, but many of them are already there. For me, the people here who are maybe still on Java 8, this is a really great article by a former Netflix engineer about how to upgrade to, at the time, Java 11. And fundamentally, the long and short of it is, it's just about kind of updating your dependencies, and in some cases, maybe a dependency is no longer supported, so you may have to change it out. And while that would be a decent amount of work, and we're all kind of always overworked, it's probably something you want to do anyways, because if by this point a library isn't supporting post-Java 8, that's probably means it's not well supported, and thus a security risk, so you probably want to move off of it anyways just for that alone, but something to consider. All the same, again, a link to my presentation. Please reach out at Billy Korando or email me, billy.korando@oracle, and thank you so much for coming to my presentation. All right, I guess we do have a couple of minutes right now for questions. So, any questions? Does anyone have a mic? Yeah, so go here first, at least.
We have a microphone or no?
Yeah, she's coming over here with it.
Yeah, I had a question about the records. I don't know if there was in there, or if there's plans for a copy, like to be able to copy everything except for one.
Yeah, like withers and Yeah, I don't know about the current status on that being implemented. I would say it's probably not going to be imminent. Like I said, the newest, the most current thing that's going to be added was just record patterns. I think that's been discussed some, but there hasn't been like a JEP created or even like a draft JEP for it. So it will still be at least a few releases out if and when it does get added. Any other questions back there?
I was just listening about Kotlin support for data classes in JPI, how it will work with record classes, Hibernate and all that stuff. Those are also immutable.
So records will never be supported by JPA because of their immutability. So entity types within JPA need to be mutable so they can like update IDs or different fields with it. So on that, records can never be entity types in JPA. However, they could be used as projections if you wanted to, if you're only just doing something for reading, or maybe you are doing like some sort of collection of different things. You could then use a record as a projection, but they can't be used as entity types. Great question. We have up here.
Thanks.
I
I would have a question related to the sealed classes. When is it mandatory to use the non-sealed specifier as part of a regular class definition? So, I mean, is it mandatory to use only when the superclass and all its subclasses are located in a single source file, or
yeah,
what
so
is
yeah,
the
you would
condition for
only non-sealed will only be valid within a sealed hierarchy. So if you create a sealed hierarchy, then if you want to be able to have anything extend off that class, you have to be non-sealed. But outside of a sealed hierarchy, if you just declared something non-sealed, then that would be a compiler error.
I see. Okay. Thanks.
Yep. And we have another question up here at the front row.
Where?
Right here, front row. Yeah.
Another question about the records. If I put an annotation on the attribute, what does that do? Is it for the actual attribute or the constructor's input parameters? Or how does it work? Basically, annotations on record input parameters.
So yeah. Annotations, to my knowledge, should work on a constructor as they normally would on any other class, because fundamentally records are just classes. Now, like, I don't know if like you tried to put like some sort of Lombok record that then tried to create like setters or something. Like, I don't know like what would happen in that case, like if it would fail, or it just create something that was like a no-op, or that would create a compiler error. Like if you tried to do a setter on a record, that would fail because like you couldn't, obviously change the value of a immutable type or immutable field. So that's it. Okay. All right. Thank you so much. And if you have any more questions, you can come up here. So thank you again.